Picture this. Humanity stands on the edge of a new era, not on Earth, but 380,000 kilometers above it. Right now, China is quietly executing one of the most ambitious engineering projects in history, the construction of the first city on the moon. Robots are already working, plans are already drawn, and the first foundations may be just years away. But here's the real question. How exactly does China plan to build a functioning city on one of the most hostile places in the solar system? Before China can ever build a city on the moon, it must first confront a brutal truth. The lunar surface is one of the most unforgiving environments humans have ever attempted to conquer. No air, no protection, no insulation, no safety net. Just a silent world of extremes where even taking a single step outside could be deadly. That's why China's plan doesn't begin with astronauts. It begins with robots. For years, Chinese landers and rovers, like the Chang'e missions, have been quietly preparing the way. Their purpose isn't just exploration. Every drill, every soil sample, every temperature reading is part of a long-term strategy, mapping out exactly what it will take to survive and eventually build on the moon. And the findings so far have revealed just how dangerous this mission really is. The first major problem, temperature. The moon has no atmosphere, which means nothing protects the surface from the full force of the sun. When the sun is up, lunar soil can reach scorching temperatures over 120 degrees Celsius. But when darkness falls, and it falls for 14 straight days, the temperature plummets below minus 130 degrees Celsius. No building can survive without extreme insulation. No astronaut can endure without protection. And no machine can operate long-term without smart engineering. Then comes the second threat, cosmic radiation. On Earth, a magnetic field shields us from dangerous particles streaming in from the sun. The moon has no such barrier. Radiation bombards the surface continuously, making long-term habitation impossible unless structures provide serious shielding, much more than simple metal walls. The third challenge is one humans barely think about on Earth. Meteorites. The lunar surface is covered in impact craters for a reason. Without an atmosphere, even tiny rocks traveling at tens of thousands of kilometers per hour slam directly into the ground, leaving behind holes, debris, and destruction. A lunar city must withstand impacts that never reach Earth's surface. And yet, despite all of this, China's confidence is growing. Because robots are already proving what works and what doesn't. In 2019, the Chang'e 4 lander carried a sealed biosphere experiment to the far side of the moon. Inside were plant seeds, fruit fly eggs, and yeast. The goal? To see if any life could survive the lunar environment when provided with air, water, and nutrients. At first, it seemed miraculous. Cotton seeds sprouted into the first leaves ever grown on the moon. But the celebration was short-lived. Within days, the extreme temperature swings killed everything inside. The experiment didn't fail. It revealed exactly how hostile the moon truly is. And that's why China's long-term strategy is structured into 3 phases. 1. Reconnaissance. Robots testing the environment and gathering data. 2. Construction. Robots building the first permanent structures. 3. Habitation. Humans arriving only when the city is safe and operational. Right now, China is deep into Phase 1, and every mission is laying the groundwork for the first ever lunar city. Now that reconnaissance is well underway, China is preparing for the next and most ambitious step of its plan, actually building on the moon. And this is where their strategy becomes truly bold, because instead of relying on Earth to send buildings into space, China wants to use the moon itself as the primary construction site. This approach is called in situ resource utilization, and it's the key to making a lunar city possible. Launching heavy structures from Earth is extremely expensive, incredibly risky, and physically limited. A full habitat module could cost billions and might not even survive the journey, much less the landing. So China wants to build the city the way ancient civilizations once did, using whatever materials exist where the settlement will stand. On the moon, that material is regolith, the powdery, dusty, rocky soil that covers the surface, and China already has a plan to turn it into buildings. One upcoming mission, Chang'e 8, is expected to launch in 2028. Its main objective: test the ability to convert lunar soil into bricks. Not metaphorical bricks, literal baked solid blocks made from moon dust. It's a simple idea with massive implications. Here's how the process would work. An autonomous robot collects lunar soil and compresses it into molds shaped like squares, rectangles, and arches. These molds are then placed in an oven, powered by sunlight or a nuclear heat source, and baked at extreme temperatures until the material fuses into a solid block. Once cooled, these bricks become incredibly resilient. They withstand radiation, they tolerate meteorite impacts, they resist the violent temperature swings of lunar day and night. Robotic builders would then stack these blocks to create walls, landing pads, research tents, and even the first protective shells for underground access points. But building with bricks alone isn't enough. A lunar city must be pressurized, meaning the inside must hold breathable air. Rectangular shapes weaken under high pressure. That's why airplanes, water towers, and fuel tanks are rounded. Curves naturally maximize strength. So China's architects have introduced a second, more futuristic concept: 3D printed habitats. This robotic system would heat lunar soil to its melting point, mix it with a bonding compound brought from Earth, and print structures layer by layer, like giant ceramic pots. These moon pot vessels, as scientists call them, would have 3 layers: an outer shell, an inner shell, and a honeycomb-like structure in between that adds strength without adding too much mass. This layered design would provide natural radiation shielding internal air pressure, stability, insulation against temperature extremes, and resistance to micrometeorite impacts. In other words, a real, livable lunar home. These printed structures could be built taller than expected. The moon's low gravity means you can climb ladders effortlessly, and with no wind or weather to worry about, stacked habitats become far more feasible. But all of this raises one massive challenge, one that China cannot ignore: power. Everything on the moon requires energy. Baking bricks requires energy. Mining regolith requires energy. Running life support systems requires energy. Solar power is unreliable because of the 14-day lunar night. Batteries are heavy and inefficient. So China plans to do something bold: build a nuclear power plant on the moon. In partnership with Russia, China intends to deploy a compact reactor to provide continuous power to the lunar base. Russia's nuclear industry, specifically the state corporation Rosatom, is one of the biggest reactor manufacturers on Earth, with experience building reactors even in extreme environments like the Arctic. For the moon, nuclear energy makes perfect sense. The extreme cold of permanently shadowed craters provides natural cooling, and the moon's already harsh radiation environment means nuclear waste adds no meaningful danger. With power, construction becomes possible. With construction, habitats become reality. And with habitats, humans can finally arrive. But here's the twist: China doesn't want a small outpost. It wants a city, a permanent foothold on the moon that will expand underground into ancient volcanic tunnels known as lava tubes. And the next mission in China's lunar roadmap is designed to find those tunnels. If China truly wants to build a permanent city on the moon, one that can survive for decades, maybe even centuries, then the surface alone won't be enough. The real frontier lies beneath the regolith, in a hidden world carved by ancient volcanic activity, lunar lava tubes. These are massive underground tunnels, sometimes stretching for kilometers, formed billions of years ago when molten rock flowed beneath the lunar crust and then drained away, leaving behind hollow caverns. On Earth, these structures are impressive. On the moon, where gravity is weaker and rock collapses far less often, they can be gigantic, big enough to house skyscrapers, farms, laboratories, and entire communities. And China knows it, because underground is where the moon becomes survivable. Inside lava tubes, the constant bombardment of cosmic radiation disappears. Temperature swings of hundreds of degrees vanish. Micrometeorites can't reach you. And structures built below the surface don't need extreme insulation or heavy shielding. It's almost as if the moon already built the perfect shelter for us. We just have to find it. That's where the next phase of China's plan comes in. In 2026, the Chang'e 7 mission will launch toward the lunar South Pole, equipped with one of the most important tools in China's entire lunar program, ground-penetrating radar. This system can scan deep beneath the surface, creating 3D maps of underground cavities, tunnels, and hidden chambers. Its goal is simple: find the entrances, find the cavities, find the future home of China's lunar city. These underground voids, revealed when the roofs of ancient tubes collapsed, give scientists a preview of what lies below: massive caverns protected from the moon's worst dangers. If the radar confirms large tunnels in the South Pole region, China will have struck gold, not for minerals, but for survival. The South Pole is already the most desirable location on the moon. It may contain deposits of water ice inside permanently shadowed craters. It receives near constant sunlight along elevated ridges. It hosts stable terrain ideal for long-term construction. Add a network of lava tubes nearby, and you have the blueprint for the first extraterrestrial megastructure. China's roadmap becomes clear. Robots build the infrastructure on the surface. Nuclear power plants provide energy. 3D printed habitats create safe stations. And eventually, the real expansion begins underground. What emerges won't just be a base. It will be the first off-world civilization zone, a place where humans don't just visit, they stay. With reconnaissance underway and underground shelters potentially waiting to be discovered, China is preparing for the most ambitious phase of its lunar strategy, constructing the first human-operated city on another world. And to understand how enormous this challenge is, we have to break down the core components of what a real lunar city would require, because it isn't just about building shelters. It's about creating an entire functioning ecosystem on a dead, airless world. And everything begins with the one resource that powers civilization: energy. No matter how many structures robots can build, nothing on the moon works without a stable source of power. China already knows that solar power alone cannot sustain a lunar city. 6 hours of sunlight per day on Earth is manageable. 14 days of non-stop daylight, followed by 14 days of total darkness on the moon, is not. Batteries would drain, solar farms would fail, life support systems would shut down. So China is turning to the one technology capable of generating power continuously for decades: a nuclear power plant on the moon. In 2025, China and Russia announced their collaboration to build a compact lunar reactor designed specifically for long-term operation. Russia's nuclear industry, through Rosatom, is already responsible for building reactors across the world, including floating nuclear plants in the Arctic. The moon, ironically, is easier to manage. Cooling the reactor is simple. Place it in permanent shadow, perhaps inside a deep crater where the temperature naturally remains well below freezing. And nuclear waste? The moon is already saturated with radiation. Storing waste there changes little. A stable power grid unlocks everything else: construction, life support, water processing, data systems, mining, transport. But to turn energy into a city, China needs infrastructure, and this is where their plan becomes even more innovative. Once robots produce bricks from lunar regolith and build basic facilities, the heavy lifting begins. China plans to deploy a fleet of automated construction machines capable of building landing pads, roads, communication towers, and multi-level structures entirely without human presence. 3D printers will manufacture curved, pressure-resistant habitats layer by layer. Bricklaying robots will assemble protective outer shells. Drones will map terrain and assist in positioning equipment. China is essentially creating a fully robotic construction crew. By the time the first astronauts arrive, the city won't be empty. It will be waiting for them, built by machines that never tire, never sleep, and never need life support. But a city is far more than buildings and power plants. It needs resources, and one resource stands above all: water. The lunar South Pole, China's chosen location, holds vast reserves of frozen water deep inside permanently shadowed craters. Extracting it will require advanced robotics, heaters, and chemical processors. Once melted, this water can be turned into oxygen for breathing, hydrogen for rocket fuel, and clean water for drinking and agriculture. This is why the South Pole isn't just a landing site. It's the future lifeline of the lunar civilization, and once water extraction begins, everything else accelerates. Greenhouses, protected by thick layers of regolith, will use LED lighting and recycled moisture to grow crops. Early prototypes will be small, but once the underground lava tubes are confirmed, agriculture could expand massively, supplying food for entire crews. Meanwhile, new technologies will transform the moon's surface into a global hub for astronomy. No atmosphere, perfect observations. Manufacturing, microgravity enables unique materials. Deep space exploration, low gravity makes launches cheap. Mineral extraction, rare metals hidden beneath the crust. China isn't just building a base, it is laying the foundation for a complete lunar economy. But the real turning point comes in the 2030s, when China begins sending humans. 5 landmark missions that will deliver each major component of the lunar city. 1. Command center, power generation, telecom, and navigation. 2. Scientific research hub, labs, medical stations, AI monitoring. 3. Resource processing plant, converting lunar soil into usable materials. 4. Autonomous exploration network, robot fleets, sample return systems. 5. Astronomy and Earth observation station, advanced telescopes and sensors. By the late 2030s, these 5 pieces merge into a functioning, connected settlement. Humans arrive not to build, but to move in. And from there, the expansion underground into lava tubes begins. The moment when China transitions from a robotic outpost to a permanent extraterrestrial colony. This isn't science fiction. These pieces already exist. Robots are already on the moon. Reactors are already designed. Lavascapes are already mapped. And China's timeline is already set. Which leads us to the final question. What happens when humanity's first city beyond Earth is built by China? As China's long-term roadmap becomes clearer, one reality is impossible to ignore. We are witnessing the beginning of a new era in human civilization. Not a space race built on flags and footprints, but a competition for permanent presence beyond Earth. And China isn't planning a symbolic mission or a temporary base. They are planning a city, a functioning, expanding settlement that could redefine our future in space. But what does it actually mean when the first city off Earth belongs to a single nation? To understand the magnitude of that question, imagine the moment, sometime in the late 2030s or early 2040s, when astronauts from China descend onto the lunar surface, not to plant a flag, but to live. Their homes already built, their energy already flowing from a nuclear plant, their tunnels already mapped beneath the lunar crust, their city already glowing with the soft light of a self-sustaining ecosystem. For the first time in human history, a group of people will wake up on another world, not as visitors, but as residents. And that changes everything, because once a nation establishes the first permanent foothold on the moon, they gain something far more valuable than bragging rights. They gain influence, they gain infrastructure, they gain opportunity. A lunar city can become the gateway to deep space missions, a platform for mining rare metals, a hub for off-world manufacturing, a launch pad for Mars, and beyond, a global center for astronomy and observation. And China knows that whoever builds the first lunar city sets the tone for the next century of exploration. This is why other nations, especially the United States, are accelerating their own lunar programs. NASA's Artemis missions aim to return astronauts to the moon this decade, followed by a base camp concept. But where NASA is proposing a small scientific outpost, China is building something far larger in scope, a multi-phase megaproject designed to evolve. China's lunar city is not just a base, it is a prototype, a testbed for future habitats on Mars, for asteroid mining stations, for orbital factories, for interplanetary civilization. But beyond geopolitics and competition, there is an even deeper question. What does this mean for humanity as a whole? For the first time, we are seeing a practical blueprint for living off Earth. Not science fiction, not theory. A real plan, one built with robots, reactors, tunnels, water extraction systems, 3D printed structures, and decades of preparation. A lunar city means we no longer see Earth as our permanent home, but as the beginning of something much bigger. And if China succeeds, they will have proven that human civilization can expand beyond its birthplace, that we can survive without an atmosphere, that we can build where there is no air, no weather, no natural protection, that life, our life, can exist in the stars. So we're left with a final, powerful question. Who will shape the future of the moon? And what kind of civilization will we build once we get there? Because the moon isn't just the next destination, it's the first stepping stone to everything that comes after. If this journey into China's lunar ambitions fascinated you, don't forget to leave a like. It really helps this content reach more curious minds. Make sure to subscribe so you don't miss the next chapter of humanity's greatest adventure. And tell me in the comments, do you think China will really build the first city on the moon? Or will another nation beat them to it? I'm reading every comment.